Okay, Chapter 3, Derivatives. So here's another example. And just to review, the difference quotient gives the average rate of change as function x goes from x to x plus h. It's actually the slope of the secant line. It's basically the same formula. It's just a different notation for the same formula as the slope that you may have studied in intermediate algebra. But anyway, this gives the slope of the secant line. And then if we take the limit as h goes to 0, we get the slope of the tangent line, which represents the instantaneous rate of change. So anyway, this in this example here, we have a function f of x equals 1 over x minus 2, and we want to find the derivative. So that's the so that means the instantaneous rate of change. So so f prime of x, the formula for f prime of x is the limit as h goes to 0, f of x plus h minus f of x all over h. So if we apply it to this function here, we want to replace x by x plus h in the formula for f of x. So we'll have 1 over x plus h minus 2 minus 1 over x plus, or x minus 2 rather, and then all over h. We want to get a common denominator, so we can multiply top and bottom of the first fraction by x minus 2 to get a common denominator. And we'll write this as limit as h goes to 0 of x plus x minus 2 over x plus h minus 2 times x minus 2 minus x plus h minus 2 over x plus h minus 2 x minus 2. And this whole thing is over h. So I'm getting a common denominator by multiplying top and bottom of each fraction by the denominator of the other fraction. And once we have a common denominator, we can combine like terms. So let's limit h goes to 0. So we'll have x minus x. That's right. I'll distribute this minus sign. So we'll distribute the minus sign. We'll have minus x minus h plus 2 over x plus h minus 2 times x minus 2 all over h. Okay, so then we can cancel some of these terms. We have an x minus x. We can cancel that, and a negative 2 plus 2, that's 0. So we're left with a minus h on top, and we can, it might be helpful to put this h over 1, so then we can use the rules for fractions. The way you divide by fraction, you flip it and change it to multiplication. So this is going to be the limit as h goes to 0 of minus h over x plus h minus 2 times x minus 2, and then this is times 1 over h. So dividing by h over 1, same as multiplying by 1 over h. And then we can cancel an h on top and bottom, and that'll give us get another piece of paper here. I'm running out of room. So that'll give us the limit as h goes to 0 of minus 1 over x plus h minus 2 times x minus 2. And now we can take the limit the h's cancel, but the minus sign doesn't. We take the limit as h goes to 0, just replace h by 0 here. We get minus 1 over x plus 0 minus 2 times x minus 2. And that's x minus 0 is x plus 0 is just x, so it's going to be minus 1 over x minus 2, x minus 2, which we can write as minus 1 over x minus 2 quantity squared. So that's the derivative, and that's the formula that gives the slope of the tangent line. It's also represents the instantaneous rate of change. It's regarded as the slope of the curve at that point. And that concludes this presentation.